So this is the first example of looking at the risk correlation matrices used for market trading. In this example we can see a simple set of data that's been imported into Excel via the SmartView add-in. And this is basically a view on top of an Essbase cube that sits back on a server, and that Essbase cube actually contains about 10 billion, or probably more than 10 billion cells worth of data. And if you look at it across the whole data set, what we have is, for the time dimension, we have about 780 days worth of data in here, and we have a variety of metrics within there that we can calculate. The key one is the correlation between -1 to +1 of the combination of two different views of the risk factor buckets. And the risk factors go from curve 1 to curve 200, and for each risk factor there's a risk factor bucket of m+0 to m+24. So 25 risk factor buckets for each of the 200 curves is 5,000 different risk factor buckets, 5,000 by 5,000 combinations. So there's a very large set of data here. And you can see, because it's a combination, a correlation across two of the same, effectively correlation between different members of the same dimension, when reported against itself like this, it basically creates this triangular view of the data. So this is a risk factor matrix, and usually this is held, just for efficiency reasons, just across one diagonal, one half of that triangle. So here we're looking at it across the time dimension. If you wanted to understand a little bit more about the structure of this cube, we could open up the member selection. We can see this is, for example, a breakdown of the curves that are available, or we can see the other dimensions that are in here. We've got curve 1, curve 2, and bucket 1, bucket 2, so these are each of the buckets against that. Very simple, fairly flattened hierarchies, except for the time hierarchy, which follows a traditional pattern. And we have a measures dimension with a couple of different calculations in there we'll go into in a bit more detail. But this is a pretty powerful example of how we can hold over 10 billion cells of information in memory on Exalytics via the Essbase running on the Exalytics server. So, you know, this is running on in Excel here, and I can go and refresh this data at any point in time. This can go, and actually in this case here it's calculating and aggregating up an average across the whole of the time frame for these different calculations, the correlations, and it's bringing back across the whole of this matrix that's represented in here, which basically is not the entire matrix. We can't do 5,000 columns in Excel, but what we're doing is we're actually bringing back 255 columns, pretty much the maximum you can do by the same downwards. So that's curve 1 to curve 9 out of 200 curves, and then all of the buckets for each of those. Now if you want to compare that to some of the other things you can do within here, so with that type of view, this is actually taking a similar perspective, and it's using the Excel conditional formatting to present that as a heat map. So here we can see a similar view, looking at the value average, this time just for one particular day's worth of data. And if I wanted to, I could go and choose a different day, go and refresh that information. And that's going to go back to Excel, go and get the new information and refresh that whole page, or maybe bring back a different day's worth of data. Or if we didn't want to see it for one of those days that we had selected already, I could open up the browser and I could bring it back, and let's see see what the average was for all of January 2011. So let's go and bring that one in as well. So this is calculating it across all of the days in that time frame, showing us the average and giving us the heat map view for that perspective. Alternatively, if I wanted to understand effectively the intersection of any one of these data points and understand what's the trend been for one of those data points, I'd use something like this example here. So here we can see an example of looking at curve 8 bucket M8 by curve 3 bucket M4, and you can see in this example here how I can then go and change the selection here across the different curves, across the different buckets, to view a different selection of that data. And what we're seeing is the trend of the value average figure across that time frame. So if I wanted to see something different, say rather than bucket M+4, let's say bucket M+0, now we can see a completely different view of that data. That is 780 days worth of information for that particular combination brought back in real time. So there we go, that's one quick example. Equally, we've got these extra calculations and measures available in the cube. So if I go and select the items that are available to me, rather than just seeing the value average across a time frame, we can do things like see what was the monthly value average, or perhaps the quarterly value average in the cube held across these different days. That allows us to give a combination and a correlation of having each of the individual numbers compare. And if I go and select this on the report, I'm going to go and bring back the data from the cube. Each of those levels, you can see again, instantly brought back. If I select the cube, I expand my selection, we can now see those monthly averages are rendered on the chart as well. Perhaps if I didn't want to see the monthly averages, let's go and see the quarterly averages. There you go, so that's one good way of understanding how we can track the data and compare things over time. And I can just simply type in to here if I want to view a different set of data. There's no limitations to how I select that information, so I can do a copy, paste my quarterly value average, I can delete that particular column, I can go and refresh the data. Now that's rendering this with the quarterly value average as that second field, and that's the number that we're seeing alongside the value average. So that's one illustration of the different way you can present this data. Again, I've got the full flexibility to manipulate this data around in Excel as well. So if I want to insert a few extra lines here, suppose I wanted to compare not one curve and trend over that curve, but actually let's compare a couple of different versions of this. So let's just move this data down here so I can actually start to do a side-by-side comparison of two different combinations. I'm going to take the value average across a similar set of curves. So let's start at curve 8M8 by curve 3M4, see the correlation between those two curves, but compare that to the correlation of bucket M8 to bucket M plus 0, for example. Sorry, M plus 4 compared to M plus 0. Let's go and hit enter, let's refresh that. Now we can see trended on that chart two really quite different curves, although actually they do follow maybe a little bit of a similar pattern. One of them is vastly more variable than the other, but it's following broadly the same sort of seasonal trend. We could see bucket M plus 4 compared to bucket M plus 5 if we wanted to as well. So let's go and refresh that data. Now these you can see are actually very, very close to each other, so there's not much difference here. So what might be helpful to see is if we actually use the capabilities you have, obviously standardly in Excel, to go and do a comparison of any fields compared to any other fields. I'm going to copy that measure, paste it across the breadth of this table, and now we can see we actually have the difference rendered on that chart as well. What might be helpful is for us to also use some of the other capabilities of Excel here to do conditional formatting across colour scales. So let's do a three-way colour scale that goes from red to green, depending on whether it's -1 up to +1. And then let's have a look and see how that compares. So now we can see there's probably some particular highlights that stand out in that data that we can very easily spot. And equally, if you wanted to just see that difference charted on the table, we can just change the scope of our graph to show that in this way here. So that's picking out where the key pieces of information are. So 4th of May 2010 was where we had a significant peak in that data. So I can go and find 4th of May, and we will go and find that one there. So that's the item that's highlighted on that report. So another thing we can also do within Excel, and SmartView particularly against Excel, SmartView against Essbase, is that this is not just a read-only cube. So if I actually wanted to do some what-if scenario analysis, I could actually type in potential adjustments to this data and then see how that might be rendered on the charts as well. So here we can see there's quite a close correlation to these data sets, but if something tells me that I think that M plus 5 in future perhaps might change, might increase by a certain different ratio compared to M plus 4, I can simulate how that might actually look by adjusting the numbers on this report. So if I was to take something like the M plus 5, now the value average itself is something that's calculated, rolled up so I can see it at any level of the cube, so I can see averages across time, across months, quarters and years. The actual data itself, the raw data, is written into the correlation value field. So I'm actually going to swap value average for correlation value, which should actually give me the same numbers. At the day level gives me the same numbers, but this is actually now a value that I can provide adjustments to. I can write back into this cube by adjusting the data. And I can either do that manually, typing on any one of the cells, or I could say, let's actually perform a deliberate adjustment by a specific fixed value, or by increasing or decreasing the value by a certain percentage. So if I say let's decrease the size selected, say percent. For this data set here. I can go and do that. The adjustments, we can see that this has been highlighted now that it's dirty data, needs to be submitted back into the, we can actually see Instantly, a bit of a highlight on there because this is held locally, so the spreadsheet sees the differences. But if I submit the data back into the cube, now we can see that those cells have gone clean, and if I go and refresh that data again, that stays in there. So now we can see, held against this data, a slightly different trend for the start of this chart compared to the end of this chart. So that's a good example of how you could actually use the write-back capabilities to make what-if scenario adjustments within Excel against a cube running on Exalytics with 10 billion records of data in it. So this is a pretty powerful example. And beyond that, you can also take the advantage of some of the calculation capabilities and the calculation engine that Essbase provides. If you don't want to be restricted to what you can do within an Excel environment, you can actually use calculation scripts to go and perform things like exponential forecasting across trend lines, using seasonality trends, etc. So there's a great deal of flexibility you can apply to take this even further if you want to.